Good morning, everyone. This is T. Shivapriya, Assistant Professor, Department of Physics from St.Josephs College of Arts and Science for Women, Hosur. Today we are going to discuss about synthesis of nanostructured materials by ball milling method. In recent years, nanoscience and nanotechnology has emerged as one of the most important and exciting forefront areas of interest in almost all fields of science and technology. This technology provides the path for many breakthrough changes in the near future in many areas of advanced technology application. The word nano means dwarf in Greek language. It can be used to prefix to any unit like a second or a meter and is equal to 1 billionth of that unit. That is 1 nanometer equal to 1 into 10 to the power of minus 9 meter. Nanoscience and technology is an interdisciplinary area of research and development. Technology is the making, usage and knowledge of tools, machines and techniques in order to solve a problem or perform a specific function. Nanoscience is the study of structures and molecules on the scales of nanometers ranging between 1 and 100 nanometer. Nanotechnology utilizes in a practical application such as devices, etc. The nanostructured materials with ultra-fine grain size are in the order of 1 to 100 nanometer can be produced with different dimensional. The different forms of nanomaterials are 0, 1, 2 and 3 dimensions. There are plenty of methods to synthesize nanomaterials. These methods are grouped into two categories, namely top-down and bottom-up techniques. The techniques are classified based on the phase of the starting material. In the top-down class of techniques, the starting material is in solid state, whereas in bottom-up techniques, the starting material is either in gaseous state or in liquid state. First, top-down approach refers to a subtractive process. This means in which a bulk starting material can be divided into smaller ones of nanosize. Then bottom-up approach refers to an additive process. In bottom-up approach, nanostructures are built atom by atom or molecule by molecule. Depending upon the requirement, we have to select an appropriate method for preparation of nanomaterials. The figure shows the synthesis of a nanostructured materials by top-down method. In top-down method, the bulk solids are broken into a finer pieces until the particles are in the order of nanometer. Figure shows the synthesis of nanostructured materials by bottom-up method. In the bottom-up approach, the nanostructured materials are synthesized by assembling the atoms or molecules together to form the nanomaterials. The top-down and bottom-up method consist of different techniques for the synthesis of nanostructured materials. For example, mechanical grinding, lithography, etching, erosion are some of the techniques used under top-down approach for the production of nanomaterials. The techniques like chemical precipitation, gas phase agglomeration, chemical vapor deposition, physical vapor deposition, sol-gel method, electrochemical deposition are used to obtain the nanomaterials under bottom-up approach. However, one has to select the right technique for the synthesis of nanomaterials for specific application. One of the main problems of the researchers is the production of large quantity of nanomaterials. Some of the methods which are used in top-down method can be easily scaled up to produce a large quantity of nanomaterials. Here we are going to discuss about ball milling method. Ball milling method is the production of nanomaterials by top-down method. A conventional method for the particle size reduction includes milling, grinding, jet milling, crushing, etc. Ball milling is an efficient tool for grinding materials into fine powders. The ball mill is generally used to grind different kinds of materials and to obtain ultra-fine powders. It is widely used in ceramics and chemical industries. There are two types of grinding or ball milling method that are available, namely dry and wet process method. A ball mill, also known as the pebble mill or tumbling mill, is a milling machine that consists of a hollow cylinder containing balls mounted on a metallic frame such that it can be rotated along its longitudinal axis. The construction of ball mill is shown in the figure. Ball mill consists of a horizontally rotating hollow cylindrical shaped vessel. The length of the vessel slightly greater than its diameter. The mill is partially filled with the balls of steel or pebbles which acts as the grinding medium. Different materials are used as a media, including ceramic balls, flint pebbles and stainless steel pebbles. The material is fed through a hollow trunnion at one end and the product discharged through a similar trunnion at the opposite end. The outlet is covered with a porous screen to prevent the loss of the balls. Working principle of ball mill method. This is based on the principle of impact and attrition. Attrition is nothing but the reduction or decrease in number of size or strength, like that. The material is fed through a feeder device at one end of the hollow trunnion. The ball mill is filled with balls which could be of diameter occupy 30 to 50% of the mill volume, and its size depends upon the feed and mill size. In a ball mill, the cylinder vessels start to rotate at slow speed and the balls which are present inside the vessels starts to roll and cascade over one another, providing an attrition action. As the speed increases, the balls are carried up the sides of the mill and fall freely onto the another material with an impact action, which is responsible for the most size reduction. The product discharged through a discharge port which is present at the another end of the cylinder vessel. The operation of ball mill method is shown in the figure. The figure A represents the sliding at low speed and providing an attrition action. The figure B shows a cascading at optimum speed, it providing an impact action. The figure C shows a centrifuging at high speed. Here the balls are held against the mill casing by centrifugal force and revolve with the mill. The speed at which the balls just being to centrifuge the mill, the lower speeds are mainly for finer grinding and the optimum speed responsible for the most size reduction. Finally, in ball mill, the large ball tends to break down the coarse feed materials and the smaller balls help to form a fine product by reducing white space between the balls. Some of the methods influenced by a ball mill method, they are the size, density and the number of the balls, residence time of the material in the mill chamber, rotation speed of the cylinder, feed rate and feed level in the vessel. Nowadays, ball mill method is used in pharmaceutical industry. They are the small and average capacity ball mills are used for the final grinding of drugs or for grinding suspension. The maximum capacity ball mills are used for milling ores prior to manufacture of pharmaceutical chemicals. The selection of materials of the balls plays an important role. Generally, a harder material will be selected to synthesize a softer materials. For example, alpha alumina and zirconia are used widely as a ball for synthesizing the nanomaterials in view of their high grinding resistance values. Following the advantages of ball milling are: it is used to obtain nanostructured materials at a low temperature. It is very cost effective and eco-friendly technique. It is used in milling highly abrasive material. It is possible to obtain large quantities of nanostructured materials. Here are some of the disadvantages also in ball mill method. Sometimes contamination of product may occur as a result of wear and tear, which occurs principally from the balls and partially from the casing. Relatively long milling time. It is difficult to clean and machine after use. High machine noise level, especially if the hollow cylinder is made of metal, but much less if rubber is used. Thank you for watching.